Okay guys, finally, I hope that the problem is resolved now. Can you hear me now? And see my screen? Let anyone know. Okay, if you can hear me now, please tell me. Okay, great. So let me also change the link of the stream. Okay, I will change it here. I'm sorry guys, with the new laptop there was some issues. I never streamed on this new laptop, so the screen wasn't showing. So I will try to fix it for the next streams, but for this one, this issue happened. I'm sorry for it. So if you're ready, we can start talking about the problems. This stream is also updated in Codeforces as well, so if you refresh the page, you can see that there is a new link there. Okay, awesome. Thank you for your patience. And let me refresh it. These two problems are red right now because I think they are in the process of judgments. Yes, they are in the process of judgments. I haven't received the wrong answer. The contest, yes, I was saying that in this contest, I was thinking about the problems, and the first two problems I mistakenly read them wrong, and I was thinking that how hard they are. I will tell you that what was my first interpretation from the first two problems, but I was just thinking that why this is so hard and so on. But I read the problem again and I understood, this just wants this. It had two interactive problems, and I liked the interactive problems kind of. So without any further ado, let's start talking about the problems. The first problem, 2 min 2 max. It just wants you to find 4 indices I, j, k, and l such that ai minus aj plus aj minus hk plus ak minus al plus al minus ai would be maximum. And all of them are absolute values. For this problem, first of all, when you see this problem, you think that it's better if you have an absolute value of difference, it's better to maximize one of them and minimize the other one. So it's always better to use the numbers which have the most difference to each other, the maximum and the minimum, as much as possible. In this problem, the idea is to find out the 2 maximum numbers and 2 minimum numbers. And the answer is gonna be, let me write on my screen. The answer is gonna be, if you have 2, you consider 2 maximum numbers, mx1 and mx2, and 2 minimum numbers, mn1, mn2. mn1 is the lowest and mx1 is the greatest. You can just have all the 4 pairs like this, each 2 of them to each 2 of these minimums. So your answer is gonna be 2 times mx1 plus mx2 minus mn1, 2 times mn1 plus mn2. This is the way that you can solve it, because these indices can be anywhere. But what I initially thought was that I is less than j, j is less than k, and k is less than l. So I was thinking that they should be in order, and I was thinking about it, and I was implementing a dynamic programming And I was wondering that why div 2a is like this and why everybody have solved this problem. And then I read it again. I said, oh, it just wants 4 indices, I, J, K, and L, and they shouldn't be in order. And when they shouldn't be in order, it's better to maximize the differences. So we pick the 2 maximums and 2 minimums. Is the first problem okay, or you need more details for it? Skip to problem B or more details for problem A? Okay, if no one has any question about problem A, we will move on to problem B. And D1 got accepted. Yeah. Problem B. Oh, I misread this problem as well. This problem is saying that you have 5 different types of coins, each with a value equal to one of the first 5 triangular numbers. A triangular number is a number like this: x times x plus 1 half. Or in other words, any number that can be wrote like x choose 2. X choose 2 is x times x minus 1 divided by 2. Any such number is called a triangular number. Okay, so this is the definition of a triangular number. So in this problem, it gives you some number n, and it wants you to have the minimum number of coins such that the sum of them is exactly equal to n. I thought that we have all the triangular numbers, not only the first 5 ones. And I was thinking about it. I knew that greedy approach won't work, and I was thinking to come up with another idea. But it only wanted these 5 numbers. So, for these 5 numbers, there's something that we should easily say. When we see this, you know, how we should approach such a problem in a contest. You know, when in a contest you see this problem, you can assume that if the number is sufficiently large, it's better to have the maximum number as much as possible. For example, if your n is greater than 100, it's never optimal to when you can take 15 from it, it starts taking 10 and 10 from it. So you won't stop taking 15 from it until it is greater than 100. Because it is sufficiently large, it is not always true. For example, if your number is something else, for example, if your number is 12, the greatest number less than is 10. But if you take 10 from it, then your answer is going to be 3, because you're going to need 1 10 and 2 1s. But if you use 2 6s, the answer is going to be 2. So this greedy does not always work, but the point is when your number is sufficiently large, when it is large enough, then you are sure that when it is large enough, it's better to use the maximum number as much as possible. Because if you stop taking maximum, for example, your n is still greater than 100. It's, for example, 120. If you start taking 15 from it and take it 10 by 10, it's gonna be way more than if you take 15 from it. So the point is, while n is greater than 100, we take 15 from it. It's just a simple division. You see that how many 15 you should take from it to make it less than 100, and for the numbers less than 100, you can use dp, for example. So this was my approach. When I saw that it just wants these 5 numbers, I promptly think that, okay, then if it is like this, then it's obvious that if n is sufficiently large, it's best to use 15 as much as possible. And then when it becomes small, I can just use a simple dp. And this was my solution for it. So I just have a dp for first n numbers, and I first said that if it is, I made it less than around between 70 and 100, it is just a sufficiently large number. It is not a fixed number. It's just sufficiently large. And then I use dp. Guys, in what language you're talking? I can't understand you. Yeah, there's a solution that someone says that greedy fails for 15k plus 8 and 15k plus 20, 10 only. Maybe that's possible. 15k plus 10, no, for that greedy won't have any issue. 15k plus 10, because it takes many 15s and then it takes one 10. But it is possible that it has other solutions that you can use. But when I saw this, I immediately thought of doing this. Guys, please speak English here, because nobody can understand you otherwise. And people in here are from different countries, so it's the best if you talk English, so that we can understand as well. Binary search, if you fix some value k and try to make it with at most k coins, I'm not sure that's gonna be a good approach. I'm not sure that that's gonna be a good approach. So I believe that that might not work. But let me think that other than the solution I thought of, is there any other easier solution? I just thought of it and I saw that its implementation is also easy, so I implemented it promptly. But has anyone solved it with a better solution? Sorry, let me pick my charger. I'm running out of charge as well. Okay. "30 minutes and I'm ready for answer of first 30 numbers." What if you use brute force? Okay, you didn't understand my solution, or you didn't understand the second solution that we were thinking. Okay, guys, all we're saying is that when your value, when your number is sufficiently large, for example, your number is greater than 100, then you can simply say that you need to take as much as 15 as possible. Okay, if your number is greater than 100, you know, it's not optimal to ignore 15 if your answer is greater than 100. So while my value of n is sufficiently large, I can take the maximum number out of it. I keep taking 15 from it. For example, assume that my number is 159, for example. I keep taking 15 from it. So the next time it's 144. The next time is 129. The next time is 114. And the next time is 99. I keep taking 15 from it until it becomes less than 100. Why? Because if n is greater than 100, it's so large compared to these numbers that I have. So it's best to take the maximum number as much as possible, so that we can reach less than 100 as soon as possible. So when your number is sufficiently large, it's best to take the most out of it as much as possible. But when it becomes small, that won't work anymore. For example, when it is 12, you can't act greedily and first subtract 10 from it and then 2 ones, because then that's gonna be 3. Then your answer is gonna be 3. But if you use 2 6s, that would work. Okay, so the point is, you know, the intuition behind it is that when you see a problem like this, the main point is this. By seeing this, you see that when your number is way larger than the number of coins that you have, the amount of coins that you have, then it's the best to take out as much as possible. Okay, and then when it becomes small, then you can use a DP or something like that. You can use a DP. And in here, I did the same thing. For the first 100 numbers, I used DP. And this 100 is okay. I mean, it's just sufficiently large. You can use any number. I just set 100 because I want it to be sufficiently large. Maybe even for smaller numbers it would work. Maybe for bigger numbers also it works, but it's slower because you need to calculate everything till end. So I chose 100 to be sufficiently large because the point is if your number is, for example, greater than 100, for example 117, and you don't use 15 anymore. If you don't use 15 anymore, each time you can reduce at most 10 from it, right? So let me prove it formally if you need a formal proof for it. Let me prove it formally. So assume that your number n is greater than 150, for example. Okay, your number is greater than 150. Okay. So if this happens, you can, with at most floor of n over 15 plus 14 operations, you can do it. You can do what you want. With at most n floor of n over 15 plus 14 in the worst case scenario, because you can take out 15 as much as possible and then the remaining is 14 coins, and worst case scenario you can use 14 once. So your answer is gonna be at most this much, floor of n over 15 plus 14. Do you agree with this? So the first fact that I prove is that my answer is always, for any number n, is at most n over 15 plus 14. Let's for now also even forget about the lower bound of n. For any number n, I say that my answer is at most floor of n over 15 plus 14. Why? Because I can take this much 15 out of it, and the rest of it, in the worst case scenario, I can do many ones and make the rest. Okay, so if, for example, it is 15k plus r, with k plus r coins, I can do what I want. Do you agree with this? So the point is, this is one solution that I have. This is not the most optimal solution, but this is a solution that I have. On the other hand, if I don't use 15, assume that at some point I stop using 15. I say that, okay, from now on I won't use any other coin of with amount 15 anymore. My answer then is gonna be at least n over 10. It's gonna be at least sale of n over 10. Do you agree with this? If I don't use 15, if I keep taking out 15s, and at some point I stop taking out 15s, I say that, okay, 15 is enough. I'm gonna use smaller coins from now on. Do you agree that if my current value is n, then it's gonna take at most, at least n over 10, sale of n over 10 additional operations? Okay, so if I just prove that this is greater than this, I show that it's not optimal to take out 15 coins of value 15. And how can I say that? I mean, what n can I set that this holds? I can just set, for example, 1,000. You know, it's just a large number. If it's sufficiently large and there's no limits, I can do it as large as I want because it won't have any effect on time limits. So you will solve the problem anyways. Assume that I set n as 1500. If I set n as 1500, this value is gonna be 114. This value is gonna be 150. So now I showed that for numbers greater than n over 15, n over 1500, it's not optimal to stop taking out 15s. So what I can do is to just start from solve the problem for the first numbers up to 1,000 and 500, 1500. Use DP, and then when I receive an n, I find out how many 15 should I take out from it so that my numbers becomes less than this, and solve the rest using dp. I say that I need this much 15s and I will solve the rest using dp. So this way I can just solve it for this much. So I just set a number, I calculate till there, and then I'm done. And the time limit is okay. You don't need to minimize this number. You don't need, you know, I used 1500, but I could use a number way smaller than this as well, but there's no difference. All of them are small and the time limit won't get affected by it because this is just 1/4. I could say here 1500. Also 100 works as well. And maybe smaller numbers are okay as well. Maybe others have used, I see that others suggested 30, 70. Yes, but there's no difference. Okay. So are you okay with this solution, guys? Did you completely understand? First, I told you about the intuition, and then because I saw that it seems that it's a bit problematic, I just tried to prove it formally. Need minus 70. I just did it because I'm saying that I try to make this number small as long as it is between 70 and 100. These are some random sufficiently large numbers. So I did this because I said that how much n is greater than 70. Divide that by 15 and use that much 15 coins. So after that my number is gonna be between 70 and 85, right? Because it's less than 85. It's gonna be between 70 and 84. Because as much as I can take 15 out of it so that it becomes greater than or equal to 70, I take 15 out of it. So this is just a random sufficiently large number. This is also a random sufficiently large number. There are no calculations behind it. The whole idea is that when n is sufficiently large, I can keep decreasing it. Did you understand it, guys? Find mistake in your code. I think that if anyone can check that out and write in the chat, that would be great. If that's possible. Okay, so let's move on to the next question. Okay, all my problems got accepted. Let me see that. What was my rank? Oh, I'm 120. Tourist is 14th. Okay, so I did not really perform well, but it's okay because I read the problems wrong and I wasn't in a very good shape. But tourist did not perform very well as well, unfortunately. Okay, so let's move on to the next problem. So in the next problem, we have 2 mines in an n by m grid. Each time we can ask a specific cell and find out and it will tell us what is the minimum distance of that cell to one of the mines, to the closest mine. And the answer to this, so you have to ask at most 4 questions in such a way that you will understand the position of at least one mine. Okay guys, the main point in here is that you should take care of these points in the corner. You know, if you choose these 2 points, you know, if you choose a corner, then your answer is gonna show you a diagonal. For example, if your answer is D, it's gonna tell you, for example, if you choose the cell number 1 and 1. If it's tell you D, then your answer is gonna be in a diagonal. You know that there is a mine in this diagonal. And then when you use the other corner, again you're given a diagonal. So this is the main idea in here. You are gonna receive a diagonal after asking each of the corners. Do you agree with this? Guys, please, I ask you again, please speak English, since it's better if everybody understands what you're talking about. I myself can't understand what you say. Okay, I've also changed it. Okay, so it's a diagonal. Okay, so the point is the intersection of these two diagonals, there might be a mine or they might not be a mine in here. It's possible that there is a mine in here, and it's possible that there is not a mine in here. Why? Because maybe one of your mines is here in this diagonal and the other mine is here in this diagonal, right? So we are not sure yet that there is a mine here. So what we do, the next time we ask this green square, we asked it and see that if the answer is 0 or not. If the answer is 0, it means that that place really has a mine. So we're done, we solved the problem. So we first ask this corner and this corner, then if these two diagonals had any intersection, I just ask that intersection and I will see that if the answer is 0, if the response I get is 0 or not. If it was 0, then it means that there is a mine there. So I just print that out and move on to the next test case. Is that okay so far? Yes, fucking simple. Right, exactly. It doesn't look like that, but it's really simple. Yeah. Okay, awesome. So if it was 0, then we're done. But what if it was not 0? Then I will ask this corner. And I will see the intersection between this diagonal and this diagonal. And this time, for sure, there is a mine in this pink cell. Why? Why for sure there should be one in here? Because because after asking the first question, we know that one of the mines should be here and one of the mines should be here, because these two point out to different mines. You know, these two corners point to different mines, and for sure one of them should be here and one of them should be here. If they don't intersect, if the first two don't intersect, we do nothing. We are sure that there's no mine. We are sure that these two mines are different. So only if they had intersection, we ask that cell. That's possible that there is a mine there. But if they have no intersection, then definitely they are pointing to different mines. So after asking this, we know that one mine is here and one mine is here. And we know that this distance is less than or equal to this distance. In other words, this one is closer to this corner than this one. I mean, this distance is more than this distance. Let me show it with the black color. The black line is longer than this brown line. Okay, so definitely this mine is closer to this corner than this mine to this corner. So we are sure that the left mine is gonna be closer to the lower left corner. So the second time when I ask this one, I'm sure that these two cells are pointing out to the same mine. So I can say that definitely there's gonna be an intersection between these two diagonals, and definitely there's a mine there, and I will print that out. Is the solution clear? Should we jump into code? I want to show my code to you as well. Are you okay with the solution? So the summary was that we choose the two corners on top. And then if they had intersection, we check their intersection of those the two diagonals that we have. And we ask that. If the response was 0, it means that there is a mine there. And we print that out. If they didn't have intersection, or we asked that cell and the answer was not 0, it means that there is not a mine there. If that happened, I will ask this bottom left corner, and I'm sure that the bottom left corner and the upper left corner, their diagonals will for sure intersect, and in their intersection there is gonna be a mine. Okay, awesome. So that's the whole solution for it. So I just print that mine out. So let's move on to the solution, to my code. In my code, I just first ask 1 and 1, as I said, then I ask 1 and m. And then I find the intersection. How do I calculate the intersection easily? I just say that, okay, this point is 1 and 1. This point is 1 and m. If there is a mine in their intersection, that mine should be somewhere here. That mine should be somewhere in here. And this distance is d1, this distance is d2. So the point is, if you add d1 and d2 and subtract m minus 1 from it, m minus 1 is this length. If you subtract m minus 1 from it and divide it by 2, it gives you that how much this row is lower to the first row compared to the first row. Because this one has these two parts and this one has these two parts. I'm subtracting this m minus 1 from them, and then I will divide it by 2 because this part is calculated twice. Then I have how much they are lower to the first row, and I add 1 to it because it's compared to the first row. And then I will find the row, and when I find the row, I find x, I say that y is gonna be d1 minus x plus 2. First, let me answer your question. Why divide by 2? No, if I subtract m minus 1, it gives me 2 times row. Because, you know, if you see this green part and this blue part, this section is calculated twice, both by the green part and the blue part. When I subtract m minus 1 from it, it is calculated twice. So I need to divide it by 2 to calculate it once. That's the reason that why I divide by 2. One of them is this and one of them is this. First, I remove that part above, and then I should subtract this by 2. Awesome. And when I understood what is the value of x, y is gonna be calculated easily as well, because I know that x plus y is gonna be d1 plus 2. Why? Because x minus 1 plus y minus 1 is d1. Because the distance from point 1 and 1 is d1. So this way I can find out what is the distance to the if I know the x, I can just subtract x plus from d1 plus 2 and find out the value of y. And then if that was inside my grids, this is why, you know, I ask this if, because it's possible that these two diagonals do not intersect, and the x and y that I find out do not make sense. I mean, they are negative or something. If these two diagonals do not intersect, this x and y might not make sense, and their value might not make sense and be in the grid. If it is in the grid, I'm sure that that cell has the same distance. But if there's no cell in my grid that has the same distance, x and y are gonna be nonsense. So I check that if it was in the grid, I ask it, and I get the value of d3. Oh guys, I'm sorry, I now see that some part of what I wrote is behind my picture, behind my video. I'm sorry for that. So here D3, I get D3, and if D3 was 0, then I'm done. And if this was outside of the grid, I say that it is equal to -1, so that I know that it is not 0. And if it was not 0, I just ask this bottom left corner, and then I find x and y similarly. Does this make sense? Is it completely okay for you? If you have any questions about it or any part is unclear, tell me to explain it again. There's no problem, I can explain it as long as you want. So if you feel that you're not comfortable with it, please tell me to explain it again. Don't hesitate to ask me. Can you also elaborate on how to do if you start from center? If you start from center, it would be a bit problematic because the set of the points that it might be in is gonna form something like this. It's like we have 4 diagonals, and it's not gonna be simple. That's why if it's me, I prefer not doing this. But maybe you can ask center and the cell next to center and see. Does anyone have any idea about it? If we first ask center, has anyone solved it like this? Yeah. Okay, so because you are saying that you prefer to move on to the next problem first, I will move on to the next problem, but that was a good question. You can also think about this as well. If we start from center, what happens? About the next problem, solo version. This problem, you meant that how to solve an interactive problem. You know, in interactive problem, nothing important should happen. The only thing that you need to say, you have to print end line after each line of your code. That's all. You know, you will interact, your code will interact with judge. You print something, then you receive something from judge. And then according to that, you will write something, and then judge according to that will give you something. So you need to interact with judge. So you need endl instead of \n. Why? Because endl has something that's called flush. Each time that it prints something and you will go to the next line, it will give it to judge in simple words. It will give the current line to the judge. But if you write \n, it's possible that it will buffer it. It won't give it to the judge. It keeps it and then gives multiple lines to judge at the same time. So when you see out endl, once you see out it, the judge will receive this number. So you need to make sure that in interactive problem you will use endl, not \n. Okay, that's the only thing that you need to do. That's the only thing that is mandatory. And you don't need to do anything else. Just do this and you're done with interactive problems. You give things to judge and you receive things and so on. Awesome. Okay, for the next problem, problem D1. Oh yeah, you don't need, there's no issue of doing that, but you don't need that. You can just see how to handle. So in this problem, given an integer variable x with the initial value of n, a single break operation consists of the following steps. Choose a value y such that y is from 0 and x, and x or y is between 0 and x. Update x, either setting x equal to y or setting x equal to x or y. Determine whether it is possible to transform x into m using a maximum of 63 break operations. If it is, provide the sequence of operations required to achieve x equal to m. You don't need to minimize the number of operations. So you have a number x, you want to see if you can change it and make it to some number y. Make it equal to some number y. So you have x, you want to change x and make it equal to y. So you have to see that whether it's possible or not, and then what is the how you can do that using at most 63 operations. First, let's think about what happens. You know, when I see this problem, the first thing that I think about is that, okay, when the answer is -1, I mean that when I cannot transform x to y. Okay, the first question that arises in my mind is this. Because the problem asks that if it is not possible, print -1, otherwise print the operations. So the first question that comes to my mind is that when the answer is -1, and I think about that. So first I will look at the test cases, I will look at input, and I see that, for example, 4, 2 is -1. So I try to analyze that. I see that I have 4, which is 1, 0, 0 in binary representation. For sure, binary representation helps a lot in such a problem because everything is x or etc. So it's good to work with binary digits. And 2 is 1, 0. So it's saying that you cannot change 1, 0 to 1, 0, 0 to 1, 0. So why is that? Well, the first thing that I have to point out is that the conditions that we have on y, one of them is that y is from 0 to x, y is greater than 0 and less than x. And the other one says that x or y should be between 0 and x. This condition says nothing other than the greatest bit of y, the greatest set bit of y. So the greatest one that y has should be 1 in x as well. Let me change these variables to a and b initially, or n and m as the problem has set. We want to turn n into n because I don't want to confuse this with this x and y. So our operation is that initially when we have number x, when we use some number y, y should be between 0 and x or y should be between 0 and x as well. So the point is that this happens if and only if the greatest set bit of y is 1 in x. Because when you take XOR, it just flips all the bits which are 1 in y. You know, it takes y and it sees that it sees that which bits are 1, and it will flip those ones in x. So if you want x to become smaller, you need to make sure that the first number, the first digit that you flip, is gonna become smaller. So it should be initially 1 and it should turn into 0. So this happens if and only if the first digit that you flip, the most significant digit that you flip, is initially 1 in x and it is going to become 0. So this condition says nothing other than the greatest, the most significant bit of y should be 1 in x. Does this make sense? Do you agree with this? So this is the whole condition for x or y less than x. So this is the condition that we should have. So now when I see 2 and 4 and I see that I cannot change 4 to 2, well, I see that, well, initially the number that I'm gonna XOR with this value, the first the most significant digit of it should be 1 in x. So for sure its most significant bit should be this one, because other bits are not 0. Other bits are 0, are not 1. So they cannot be the most significant bit of y. Okay. No, least significant bit does not make it less than x. No, what I mean is that between all the bits, on bits of y, I mean that between all the on bits of y, the one which is most significant should be 1 in x. Okay, so that's what I'm saying. Because if y is gonna change some bits, y is gonna change some of the bits. It's gonna flip some of the bits. The only thing that we care about is this first bit. Because if this is 0 in x, for sure x of y is gonna be greater than x. And if it is 1 in x, for sure x of y should be less than x. So what I'm saying is that the most significant binary digit of y should be 1 in x. If it is 0 in x, then it's gonna be greater. But if it is 1 in x, it's gonna be smaller. Okay, awesome. So I know that the first one should be 1, and whatever I do, I cannot have 1 anymore after this, because it makes it greater than x. I cannot do anything. Even if I put 2 zeros, it's gonna be equal to x. Okay. So one of the main points that I should consider is that x always becomes smaller. It either turns into y or x or y. So it always becomes smaller. It never becomes larger. It always becomes smaller. So I need to make sure that my n never comes less than m. N should never become less than m in my operation. If n becomes less than n at some point, then there's no way that I can reach m from there. If n becomes less than m, then there's no way that I can reach m from there. Okay, so I need to make sure that my number never comes there. So for instance, here I have 1 in here. The next bit also should be 1, because this 0 should become 1 so that I'm sure that my n would not become less than m. So this one should also become 1, but this will make it greater than my value of x. So this is the whole idea. This gives me some intuition about what should happen so that the answer is going to be -1. All I'm saying is that as soon as you have some number x, it has some ones. Let me write x like this. This is my x. This is my x. And I have some ones in here. There are some ones in some places of it. Okay, it has some ones. These are leading zeros. Maybe I can put 1 in here as well, so that it won't have any leading zeros as well. So these are all the ones that I have. I know that when I choose a y, its most significant bit should be one of these ones. And I want to make sure that my number never becomes less than m. So there are two cases. If y and x, I know that y is less than x. If the first digit, if I consider the same length for y, if this digit is also 1 in y, then the answer is definitely yes. If this is 1 in y as well, then the answer is definitely yes. Can anyone say why? Let's making it a bit interactive. Let's making the stream a bit interactive. Can anyone say why, if y is 1, the first digit of y is 1, then the answer is always yes. Well guys, the point is that if this happens, I can choose some y, some value for y. I can set the first number in y 0, and I know that I'm gonna choose x or y anyway. Okay, I'm gonna choose x or y. That's not complete, so I need to talk a bit more about that. But yes, the summary of the problem is this: all the onset bits should be onset in y, and yes, so if I should see m, anything that is set there, I should set it in n as well. Everything is unset in there, I should set that in unset that in n as well. So all I'm saying is that if the first digit is the same, both of them have 1 in the first digits, I can say that I choose 0 for here so that x or y has 1 in here as well. And because I know that this is my m initially and this is my m, and I know that m is less than n, and I'm now sure that y is also less than n as well. I want to make x or y m, so I'm sure that it's gonna be less than x, and y is gonna be for sure less than x as well. So I can just choose the rest of them freely. Each bit that I want to change, I will change that. I will set 1 in here. Each bit that I don't want to change, I set 0 for that. Okay, I repeat it. So the first thing that I want to prove is that if this is number x, this is my n. Okay, this is the n that I got in pro. Let me make it a whiteboard maybe, so that it's gonna be more clear for you. Let's get rid of the statement. Assume that this is my number n. Oh, my old laptop can't bear a lot of pressure, so I hope that it won't be problematic. Okay, so this is my n and this is my m. Okay, so assume that the first digit of them are the same. This is n and it has 1 at some places. If m also has 1 in the first place, then the answer is definitely yes. What's the reason of that? Well, the reason is that I can choose 0 for here. And because I know that, you know, m is less than n definitely, I want to say that the value that I should x or n with is also less than n. Why? You know, I kind of put a number s in here such that n, x or s is gonna be equal to m. N, x or s is gonna be equal to m. So I choose such a value of s such that n, x or s is going to be equal to m. And I'm sure that m is definitely less than n. It's said in the problem statement. And I just need to show that s is also less than n as well. And it's obvious. Why? Because m and n are both 1 in their first digit. So s is going to be 0 in this first digit. So s is definitely less than n and the problem is done. We can just solve the problem with one operation and go from n to n. So if the first digit is 1 in m, we're done. Is that okay? Do you agree with this? Oh, you didn't understand this part? Okay, I repeat it, no problem. So all I'm saying is that I have some number n and I want to make it equal to m. Okay, so if I know that m is less than n, for sure I know that m is less than n. So I want to choose some number s so that n, x or s is gonna be equal to m. I want to choose some number n such that n, x or s is gonna be m. I know that m is less than n, so I don't need to worry about that. That's okay. M is less than n. I want to also show that that value of s is less than n as well. S is only 1 in the places that n and m differ. In the bits that n and m has different values in that place. So in those places, s is gonna be 1. And I know that in the first place, n and n are the same. So the first digit is gonna be 0. So s is definitely gonna be less than n as well. So I can use this value of s and turn n into m in one operation. And then some demo example. Okay, definitely. So an example is gonna be like this. For example, assume that your n is 11. Your n is 11 and your m is, for example, 9. Here, the first bit of the first bit of n is also 1 in m. Okay, so we have 4 digits and the first digit of m is also 1. I should choose some value of s such that n, x, or s is gonna be m. So what s should be? You tell me what s should be. I want to choose some s such that n, x, or s is gonna be m. You tell me what the value of s should be. I'm gonna wait for your answer. I know that we have a little bit of delay. Okay, now I received one answer. Yes, exactly. S should be 0, 0, 1, 0. Let me write it with another color. It should be 0, 0, 1, and 0. So this should be the value of s. Why? Because it is 0 when they are the same, n and m are the same, and it is 1 when they are different. Okay, so it is 1 when they are different and 0 when they are the same. So it's gonna be 0, 0, 1, 0. I'm saying that s is definitely less than n because the most significant bits of n and m are the same. So s is gonna be 0 there. N is 1 in there in the most significant bit, but s is 0 in there. So s will be definitely less than n. Therefore, I can say that I can freely choose my value s, and I can say that n is equal to n XOR s, and I'm gonna have the value m I want. So I just say that with one operation I can do this, and I say that my number first was n, and after one operation it becomes m. This is gonna be my output, and the problem is done. So this case that the first bit of m is also 1 is done. If you're okay with that, we will talk about the second case where the first bit of m is 0. Are you okay with it? If m is most... Yes, I will talk about the other case as well now. Okay, so this case is done. Yes, delay tube. Yeah, I'm sorry for that. Maybe I should decrease the quality of stream, and that will reduce the delay. Maybe I will definitely do that for the next streams. There are some things that we need to fix. I will reduce the quality for the next streams such that there would be less delay between me and you. Okay, so the other case. In the other case, for example, it's like this. N is 13. Sorry, n is 11, and m is, for instance, 9. Okay. Yeah, gotcha. Yeah, I should decrease the quality. So if this happens, what I say is that I should make n equal to m. So I should somehow get rid of this one. Right? So I should make that 0. But at the same time, I should make sure that n does not become less than m. This is my red line. It should never happen. N should never become less than m. If n becomes less than n, we're done. There's no way that we can solve the problem. If n is less than n, we're done. So what we can say is that, okay, consider the first two ones in n. Consider the first two ones that we have in n. Okay, this is value n, and we have m in here. And guys, this is just some leading zeros, it doesn't matter. Okay, so this is 0 in both of them. Okay, so these are the first two 1-bit set bits that n has. Okay, what I need to say in here is that if y has 1 in any of the places here, if y is 1, for example, it's possible that y is 0 in here and 1 in here, which does not contradict the condition. By y I meant m, sorry. M might be 1 in here and 0 at the beginning. That does not contradict the condition. M is going to still be less than n. If that happens, I say that the answer is definitely minus 1. Okay, if this happens, the answer is definitely minus 1. Why? Because I say that my first bits, anyway, in one operation I should get rid of this one. So one of my operations does have 1 in here. I XOR with this 1. So what I need to say is that I can set the rest of them 0, because if I don't set these 0, then it's gonna be greater than n. But when I reach here in S, when I reach here, if I set it 1, it's gonna be greater than n. If I set it 0, then n XOR S is gonna be less than m, or the new value of n will be smaller than n. So we need to take care of two things. N prime, or the new value of n, should be greater than or equal to n always, and S should be less than or equal to n as well, or less than n as well. S cannot be greater than n. So in here, if I choose it to be 1, it's gonna be S is gonna be greater than n, which contradicts the second case. If I choose it to be 0, n prime is gonna be less than m, because it's gonna be 0 in all these places, and it's gonna be less than m, and we're done. So if between the first two 1 digits of n there is a 1 in y, we're done. There's no way. The answer is minus 1. So let me show you by an example. Let me show this to you by an example. Assume that my value of n is, for instance, I don't know, y 1 0 0 0 1 1, and this is n, and my m is 0 0 1 0 1 0, for instance. Okay, if I have this case, this is one of the cases that I said between the first two ones of n there is a 1 in m. If this happens, well, I know that in one of my operations, this bit should be 1 in one of these operations. And if I consider that operation, these bits should be 0. This bit should be 0, because otherwise my number is going to be greater than n. But when I reach here, if I choose it to be 1, this is going to be greater than n, which is a contradiction. If I choose it to be 0, then n XOR S is going to be less than m, which is again a contradiction. It again shows that there's no way to fix it. So if this happens, the answer is definitely minus 1. Do you agree with this? So this is the condition that the answer is minus 1. And next I will show that in any other case I have a solution. Are you okay with this? S has to be smaller than n. The value that you XOR with your n should be smaller than n. Both S and n XOR S should be smaller than n. So maybe you need to read the problem statement again, because maybe you're not familiar with the statement. Yeah. Okay, guys. Is this case okay as well? Should we go to the last case of this problem? So this case is definitely -1, and if this does not happen, so I will continue for now, because okay, finally I received a feedback. So if this did not happen, it means that if I consider the first two ones of n, these bits in the middle are 0 in n. These bits in the middle are 0 in m. Then the problem can be easily solved. How? I can do it with two operations. Well, in the first operation, I know that this bit was also 0 in y. In the first operation, well, I just forget about this bit. Okay, I set x equal to this. First, I forget about this bit. I set s to be, and this is value of m. I set s to be 1 in here and 0 in here. And I ignore this bit. I put 0 in here so that I don't change anything. I don't care about this bit. And for the rest of it, I change it as I want. I change it and make it exactly like m. So for the last suffix of it, I make it exactly like m in the first operation. And if it became equal to m, then we're done. In other words, if this was also 1, we're done. If it was 0, in the second operation, I just give this number and I XOR it with this number, and then I'm gonna have the value of m. So I might have 1 or 2 operations, and then I'm gonna reach the value of m. Is that okay now? Have you understood the solution? So the whole point is that I ignore the second 1 bit. Why? Because it guarantees how I use the second 1 bit. I use that to make sure that s is gonna be less than n. I use that to make sure that s is gonna be less than n. And when I set it 0, then I'm sure s is less than n. So I can choose the rest of them as I want. Okay. So this is how I use the second 1 bit. This is why the second 1 bit is important. And then in the next operation, I will choose that middle one and change it if it needs to be changed. Check your code in question. See, in the middle of a stream I can't do that, but you can paste the link of your code. Maybe others who are in the stream can help you. Also, you can join our Discord server, and in the help channel in the Discord server, you can ask your question, and other people might help you. So we will definitely welcome you in our Discord channel if you join there and help the others. If you have any answers about their problems, you can ask your questions. Others will help you, you help others, and this is going to be a great community. So I invite all of you to join our Discord server. Maybe let me send the link of the Discord server here. So okay, this This is the link of the Discord server. I pinned the message as well. And if you also wanted to follow us, follow my page on LinkedIn, we put some educational materials about CP in there as well. You can follow this page. So maybe you can paste the link of your code there, and people will help you. I will also check some of them and help you other people. There are many great coders there. Omnik is there, Colin is there, Alireza Kaviani is there, I am there, Yan is there, Ahmed Khan is there, and Frodaxin is there. I'm not sure if I'm pronouncing his name correctly. So I'm not sure if they have time to check those things that you put in the channels, but when I have time, I always try to read them and answer you, and others are free to answer as well. Okay guys, are you completely okay with this solution? Let me show you my code as well. The code is like this. I just see that if the first bit was 0, the first one bit in X, it was 1 also in Y, then as I said, we're done. Otherwise, if between two ones there was a 1 in Y, this is bad, and I see out -1. Otherwise, in at most two operations, I can solve the problem. So this was this one. The summary, if that summary was for the solution, it was not complete. If that summary was for the solution, it was not complete, unfortunately. Maybe it was correct. I'm not saying that it wasn't correct, but it wasn't complete, at least. Explain the code. Yeah. In the code, I just say that I get X and Y. And if, I move forward until I reach the first 1 bit in X. If it was 1 in Y as well, then I'm done, as I said. I will see out 1 and I'm done. Otherwise, I add 1 to CNT to see that how many 1s have I seen. And when CNT was equal to 2, I will break. I will go out of this floor because I'm done. I found the first 2 ones. If it is bad, bad is equal to true, otherwise I have a solution. And the point is, if the second one was 1 in here as well, I mean if this first one was 0 in Y, but when we reach the second one, then we see that it is 1 in Y. Then again we're done, because again we can just make Y in one operation. We can choose S to be X or Y, and that's gonna be less than X, because this is gonna be 0 in this bit, and all the ones are to the right of it, and that's gonna be less than X definitely. So this case is also done. The only case that is left is that if we have all zeros in here, in X, in Y. In this case, I will solve it in 2 operations. In the first operation, I will choose these bits and change everything in here to make it exactly like Y. So after one operation, my number is gonna be Y. Only this bit is gonna be 1 in it. This bit is gonna be 1 in it. So it's gonna be 1 plus to the power of last, and last in here is the second one that I had. And then I have 1 Y, and in the second operation I make it Y. BT function is the function that I implemented. It just checks if that bit is set. Maybe my code is not in the neatest situation, because I was in the middle of contest and I was just implementing it fastly. So maybe this is not good for explanation that much, but you can understand what I'm doing here, I guess. So, is everything okay in here? If it's okay, I will move on to the last problem that I've solved in the contest. Problem D2. Well, the problem D2, I'm still watching chat, so that if you ask any question, I will get back to problem D1. But because we have some delay, to avoid wasting your time, I will start talking about problem D2 as well. Okay, yeah, sure. So the next problem D2, this is a relatively harder problem. Let me see. A question came into my mind. Oh, tourists didn't solve the last problem. Oh, so okay. So in this problem, it is the game version of the previous problem. In this case, we have a number P. And two players are playing. Each player in his or her own turn, will break this number into two numbers. It means that it makes it two numbers, P1 and P2, such that P1 XOR P2 is equal to P. Okay. And then the other player chooses one of P1 and P2. So the first player breaks the number into two numbers, and the second player will choose one of these two numbers. Okay. And they will move on, and this condition should hold. P1 and P2 should be both between 0 and P. They should be greater than 0 and less than P. So this game lasts until one of the players cannot make a move. If a player cannot make a move, that player has lost the game. And you have to play interactively. You will choose to be the first player or the second player at the beginning. It gives you what is the initial number. It tells you what is the initial number, which is n, and is up to 10 to the power of 18. It's 10 to the 18th. And you can choose you are the first player or the second player, and just play with the judge, and you have to win the game. Okay, well, the answer to this problem is this. Well, in this problem, my approach was that if my number P has, if I want to tell you about this problem, if I want to give some feedback about this problem, so that you will know that how you can reach such a solution, I recommend you to learn a little bit about NIM, the NIM game, and maybe a little bit about ground numbers, and a little, you need to have a little bit intuition about games. Okay, you can solve some game problems in Codeforces. You are not gonna use ground numbers here, but it gives you some intuition that helps you to solve this problem. Okay, all this gives you some intuition. And when you develop your intuition like this, by reading these things and solve many problems, game problems, you have some clue that's how you can solve such a problem. So, in this problem, what I did was that I considered the number P that I have. I said that there are two cases. It either has even number of ones or it has odd number of ones. Okay, so it's either even or odd. Okay. I just need to say that if it is even, then I will play first. And if it is odd, I will play second. What I want to do is to make sure that each time the second player gets number P, it has odd number of ones in it. Each time I get a number P, it has even number of ones in it. So what I do is that when I have an even number, I can easily split it into two odd numbers. I can choose the first bit in one side and the rest of the bits as a second number. So if I have some P, which is some number, in the first one, I just choose the first one, and I will have the rest of the numbers in the second one. Then both of them are gonna have odd number of ones. And whichever the other player chooses, he or she has gonna have a number with odd number of ones in it, right? So whichever he or she chooses, they will have an odd number of ones in the number. Okay, so the other player is Bob, so it's a he. So we are sure that he's gonna have odd number. But when the other player plays, if he has a number with odd number of ones, for sure the numbers that he will give you, one of them has even number of ones, one of them has odd number of ones, because the parity of the number of ones does not change. Why the parity of number of ones does not change? Because if these two numbers p1 and p2 and p, if you consider it, if p is 1, one of these two is gonna be 1. If p is 0, either both of them are 1 or none of them are 1. So the parity is the same. So if we have odd number of ones in p, in total we're gonna have odd number of ones in p1 and p2 as well. So one of them will have odd and one of them will have even. So I will choose the one which has even. So each time I have a number with even number of set bits, and the other player has a number with an odd number of set bits. So that is gonna be my solution. This is how I work. This is how I implement this problem. I'm just saying that in here. Let's wait till it loads. Guys, ask me questions if anything is not clear. Don't hesitate to ask me. I will answer any question that you might have. So this is what I do. First, if n modulo 2 was 0, CNT is just built-in pop counts. It just counts the number of ones. This finds the most significant bits, and this finds out this is from D1 problem. Just checks. I don't use it in this problem. It is just left from D1. So I'm just saying that if the number of ones was odd, then I will play as a second player, because the other player has to make it. Into one odd and one even numbers, according to the number of set bits. Then I see in P1 and P2, and until P1 and P2 are both non-zero, I just say that n is equal to CNT. If CNT of P1 was odd, I choose P2, otherwise I choose P1. And then I see out, as I said, the most significant bit of n and the rest of n. In the second case as well, when the number of set bits is even, I first see out first, and then I do this. I just separate it into two parts, which both of them have odd number of ones. And then while I see in P1 and P2 and P1 and P2 are non-zero, I just again get the number. This part is exactly this part. There's no difference. I just get these two numbers and I choose the one that has even number of ones, and I will move to that one. So I can always solve the problems. And this is a very shortcut. This problem was really beautiful. I like this one. Unfortunately, I didn't have a chance to think about the last problem. I was very slow at the beginning of the contest. I misread the first two problems. That's a very important thing. You should not misread the problem. I will think on that. It takes a little bit time until I get into the best shape of myself, but I hope I get there very soon. I tried that to don't do this mistake again in the next contest. Why does it matter that we always get even? And how are we sure that get even if we let Bob first? Okay, it is important. Why we can be sure that we get even if Bob moves first? Well, if Bob moves first, we know that the number has odd number of ones. The number of ones is odd. Okay. The number of ones is odd. So he will make it into two parts. Okay, he will make it into two parts. And as I said, one of these numbers has even number of ones, one of these numbers has odd number of ones. Why? Because as I said, the parity is the same. If this is my number P, and if these are P1 and P2, if these are P1 and P2, each bit which is 1 in P is gonna be 1 in one of them, one of P1 and P2. Each bit which is 0 in P is gonna be both 1 or both 0 in these two numbers. Okay, so each bit in P which is 1 is gonna be 1 in one of P1 and P2, and each bit in P which is 0 is gonna be 1 in both of them or 1 in none of them. So the parity of the number of ones in here and in here is gonna be the same. So we know that if we have odd number of ones in here, we also have odd number of ones in here. And an odd number, when we write it as the sum of two numbers, is definitely the sum of an even number and an odd number. So definitely, one of P1 and P2 is gonna have even number of ones. Is this question answered? Are you okay with this part? So definitely, one of P1 and P2 is gonna have odd number of ones. Even number of ones. One of them has odd, one of them has even. So we choose the even one. And why does it matter that we choose even? Well, two things is important. First, we can guarantee this. We can guarantee that we can always have even numbers. And the point is, when does someone lose? What is the situation that someone loses? And he cannot make any other operations. The only condition that someone cannot make any operation is that the remaining number has only one set bits. If the remaining number has only one set bits, then the player loses, right? So that's the only case that a player loses and the game is over. So when we are sure that always when we have P has even number of ones, we are sure that we never reach this state. So we always have something to do. So when this case happens, this is gonna be for Bob, not for us. And each time we are removing, either we are making the number of bits 1, or we are removing one of the ones from P. So the number of operations is also going to be at most 63. Yes, I can go over an example. An example is going to be like this. You know, for example, if your number P is 10110, it is your P. Now let's talk about P1 and P2. This is P1, this is P2. I say that in this bit, one of P1 and P2 should be 1. In this one, either both of them should be 1 or none of them should be 1. So assume that both of them are 0. In this one of them should be 1. For example, P2 is 1. In this one, again, one of them should be 1. For example, again, P2 is 1. In this one, either both of them should be 1 or none of them should be 1. So assume that both of them are 1. So each time, you know, the first time in here, the first digit, we have 1 1 in here and 1 1 in here. Here we have 0 1 in here and 0 1 in here. Here we have 1 1 in here and 1 1 in here. Here we have 1 1 in here and 1 1 in here. And here we have 0 1 in here and 2 1s in here. So the point is the parity of the number of ones is the same. So if I calculate that how many ones I have in P and how many ones I have in total in P1 and P2, they are gonna have the same parity. So that's the main point. They're gonna have the same parity. Okay. So when P is odd, there's gonna be odd number of ones in here. So one of them is gonna have even number of ones, and the other one is gonna have odd number of ones. Therefore, one of them is even, and we can always choose that one. And if we do that, we always have even number of ones. So it's never possible that we reach a state that we cannot make a move. We always can make a move. We know that there are at least 2 ones. So in the worst case, we can choose one to have these bits and the other one to have the rest of them. Both of them are greater than 0 and less than our number. So we can always do an operation. So even matters because when it is even, we always have an operation. We never lose when our number has even number of ones. We always have an operation to do. Does this make sense now? By the way, at the same time that you are asking questions, if you have any further question about this problem, guys, how I also would like to know that how was this stream. Awesome. I'm sorry that at the beginning I kept you waiting. I wasted your time. I'm really sorry for that. The next time it won't happen again. My mistake was that I didn't set up the new laptop yesterday. I thought that because it worked well in this laptop, it's gonna work well in the other laptop as well. But it needs that seems that it needs some more operations to do to fix it. I'm so sorry for that. I hope that it's worth it and you enjoyed this stream, you learned from the stream, you had growth. So if you have any suggestions, any feedbacks about these streams, please let me know. Also, if you want, you can give a score to the stream from 0 to 10. 0 the least and 10 the most. You can give a score to the stream if you want. It's completely okay. I mean, you can freely say that. We use these numbers to improve the quality of the streams. So it's okay if you give us a low number. It just means that we should work harder to make it better. So this is completely okay. If you want, I would be happy to receive some number from 0 to 10 from you for the quality of this stream and how it helps you. We're gonna use these numbers to improve the next ones. Jiangli used some really neat formula. Can you go over it? For which problem? Problem C. Let me see. Jiangli. Problem C. Jiangli. Problem C. Ask 1, 1, ask N1, ask 1, M, A minus B plus. Oh, it's neat. Oh, it's so cool. Yeah, it's so genius. It's just saying that my impression is this. I believe that he asks three corners. And he says that, okay, you know, there are two cases. Either all three of them point to the same mine, or it is 1, 2. I mean, two of them point to one mine and one of them points to the other mine. So he will, if he can subtract twice the mine that is duplicated, he will have one of the mines. I believe this is what he has done. So it's kind of like, if you can do something that if you have a mine twice, you can subtract it. I mean, you remove it when it comes twice, then you're gonna have the other mine, which can be the same mine or the other mine. I mean, the third mine, the third answer. So he uses the fact that if you ask three of them, one of them will be there twice. And if you can subtract the coordinate of that one, you will have one of the mines. I believe that this is what he has done. And he says that x1 is equal to a minus b plus n plus 1 divided by 2. Okay, seems like in here he is calculating the... Yes, in here he is calculating the intersections. It seems... Yeah. Okay, he does it even simpler than that. He just says that if he finds out the intersection of these two and the intersection of these two, He just find out what is the intersection of these two and the intersection of these two. And then he says that if the first one was in the grid and if you ask it, it's gonna be 0, then see out it. Otherwise, see out the other one. He has done the same thing that I have done. It's the same thing. He just asks these 3 corners. This is completely the same solutions. It gives you 2 points. They can be the same or not being the same. So these intersections give you, firstly, I thought that he has done something else, but no, he hasn't done that. He has just done what I've done. He finds the diagonals, the intersection of them, and then he checks if the first one is okay. And if it was okay, he will print that, otherwise he will print the other one, which is exactly what we said. This formula is nothing other than just finding that position. There can be for example, in here, he says that, do you remember this part? A plus B minus N. A plus B, if we can subtract N minus 1 from it, and then divide it by 2, and then add 1 to it, it gives us Y. This is exactly the same formula that I used, but it is written in another way. So that's all. Okay guys, thank you very much, Rahmatullah Mahin, for your feedback. I would appreciate it if the rest of you give some feedbacks as well and give us some suggestions to improve the quality for the next ones. How do I enhance my algo implementation skills? I mostly recommend you to have a lot of problems which their difficulty is not a lot. I have said this in one of my videos as well. This works magic, this is really great. If you can have many problems which their difficulty is not a lot and just keep implementing them right after each other. When I wanted to start CP again just a week ago, when I wanted to participate in contests, what I did was I had so many problems that were very easy and I kept implementing them. And I saw that I have stupid bugs, etc. So I learned to focus when I'm implementing. And it's awakened me, kind of. So I became maybe 50% of what I could be. I became back to 50% of what I could be. It helped me awaken my ability of implementation. So this can really help you if you solve a lot of problems with low difficulty and accept them one by one. Go over all of them and accept them one by one. That would really help you to improve. I have a Discord community. You can see the link of the server in the pinned message. So let me share it again. This is our Discord community. Make sure to join there. If you had any questions, you can ask there. Many great competitive programmers are there, and I will always see your messages. Whenever I can, I will answer your messages. We want your history of CP journey. Yeah, okay, sure. So maybe I should have interviews myself as well very soon. Maybe I can ask Colin to interview me instead of myself interviewing myself. In the episode that I'm gonna be interviewed, maybe I can ask Colin to interview me. Maybe I will tell him. But I won't interview very soon because there are many other people that I should interview first. Thank you very much for congratulating me on qualification to NAC. Yeah, I hope that we will perform well there as well. So support us. Our team is really good, but they have very great teams there as well. MIT team is very strong. They have 3 legendary grandmasters. So basically it seems like we cannot become the first. We cannot win the first place there, but we can win the second place, I believe. I believe that we can win the second place. We cannot win the first place, but we can win the second place. No, I did not grow up in USA. My English accent is good because I watched a lot of movies. I listened to a lot of English songs, etc. So over time I got used to the American accent. I'm not still very good in the American accent. I'm still learning. When I arrived here, I saw that there are many words that I'm pronouncing wrongly. I mean, for example, I kept saying this as vertices. If you see my graph video, I'm saying that a graph has n vertices and m edges, but this is vertices. I mean, the pronunciation is n vertices and m edges, not or indices, vertices. So I saw that my pronunciation on some words are wrong. So I'm learning here. When I came here, I understood. I'm improving. Is CP sheets are worth? Well, I don't know what exactly you're talking about. How to reach problem BC in Codeforces contest? Well, the best way, there is not some fixed way that I tell you and then you listen to that and you're gonna solve the problems in the next contest. You need to have training. You need to solve a lot of B and C problems. Go over the last contest, go over the last 50 contests and solve the problem B of all of them. And solve the problem C of all of them. The last 50 Div 2 contests or Div 3 contests. Solve problem B of all of them, solve problem C of all of them, whichever is your objective. If you have issue solving problem B, just go on and solve problem B on all of those problems. So, on all of those contests. So, this can really help you, and in contests you see that you're a lot more comfortable with solving those problems. At the beginning, that helps you a lot. So, that's the best thing that I can recommend to you. You have any experience in math contests? No, I have not. I haven't participated in math contests. You look like a playboy, but turns out you're grandmaster. I really look like a playboy? Well, first of all, I don't know why everyone think I'm a grandmaster. I'm not a grandmaster. I'm an international grandmaster. Algorithms with Shayan was grandmaster. You know, let me show you. Algorithms with Shayan was grandmaster because I had only maybe 5 contests in it. Let me show you. Algorithms with Shayan. I had only 5 contests or 6 contests in it, and in the first contest I won ranked 1 in all of them. In the Div 2 contest, I was very in shape at that time. I was very fast. I participated in 3 Div 1 contests, my first 3 contests, and I won ranked 1 in all of them. Now I'm a bit slow. That's been a lot of time that I haven't participated, so I have a lot of work to do to get back in shape. Yeah, I'm not a grandmaster really. I'm IGM, and I aim for LGM now. I'm grinding for LGM. I'm a specialist and I want to become expert. Is fixing rating is a good practice like C, D, Div 2 good to reach expert? Yeah, definitely. It helps you. You can fix some difficulty and solve problems from that difficulty. You can solve problems from that specific difficulty. You can also solve, as I said right now, solve problem C of all the last 50 Div 2 contests. That would definitely help you. So, is there any other questions or comments or anything? My age. How old do you think I am? How do I look? Yeah, you're right. I finish. No, not 21. Yeah, Gian Poppy, you're also right. I'm 23. I'm in the first year of my PhD. I started PhD right after bachelor. So yeah. So I hope you enjoyed the stream today, and still make sure to join the Discord server, give us your suggestions. We will try to improve our work as much as possible. Is writing new topics good or just working CDIF 2? I will tell you all this. I think that this stream was mainly about a solution discussion of round 931 div 2. So I will definitely have another stream for you to talk about all these things. I mean, I will set the topic of that stream to be exactly about this. We will talk with each other. I will give you the advices that I believe in them, and I will tell my students, and I will tell you about myself. So we will have another stream about that. But for this one, because the topic of this stream is solution discussion of around 931, I think it's better if we have this conversation, another more conversation. I thought it goes master and after that PhD. Yes, basically it's master and after that PhD, but I had a direct PhD. So I had my bachelor in Iran, and then I applied for a direct PhD in University of Maryland, and I got admitted and I came here. Yeah, so I will see you in my stream soon, the stream that we're gonna talk, and I will try to help you. Will you join that stream if I have that? I just want to have some feedback that how many of you will join. How much do you like to have such? How much do you like to have such stream? Do you like to have that? If you want, I make another stream that we will just talk about everything. Oh, you are from Iran? That's cool. Maybe some vlog from Iran. I don't live in Iran right now, so I can't record anything in Iran. But if someday I came back to Iran, sure, I will have vlog from Iran. When I started very slowly. I started the contest very slowly. As I said, I misread the first two problems, and I was thinking that why they are so hard compared to div 2A and div 2B. And I was just thinking that, yeah, I'm doing a very bad job, and everybody are watching me. I'm gonna stream the contest, and my situation is like this right now. So I didn't feel stressed. I have enough experience. I felt all of these feelings in many contests, so I could fix that, and I continued my contest. And my final rank was not very bad. I solved as much as tourist. Well, that's a good news. We can look at it like this. So yeah, but when I get in shape, I will perform a lot better. Okay guys, thank you very much. See you in the next streams. Make sure to watch the videos and give me feedbacks. If you like, you can subscribe to the channel. You can join the Discord server so that we communicate there. And so, see you. Bye bye.